Okay, here we are asked to write this polynomial, which appears in standard form. We're asked to write it in factored form. And we're going to use our graphing calculator to help us out with that. We're going to use the graphing calculator to help us find two things. One, the y-intercept, and also the x-intercepts. And once we have those, we can figure out what the factors are and what the leading a coefficient is out front. So here I'm going to open up my calculator. I've typed in the function into my y1 and I'm going to graph it. And this is what it looks like. So it looks like it has 3 x-intercepts and 1 y-intercept down here. First, let's look for the y-intercept. I'm just going to open up the table, which is you hit second and then graph to open up the table. And I'm looking for what the y value is when x equals 0. And it looks like it is at negative 15. So I'm going to write our y-intercept is at the point 0, negative 15. Next, I want to find our x-intercepts. So I'm going to open back up our table here. And just glancing, I do see 2 of them here. So the first one here is at x equals 3. Right? I'm looking for wherever the y value is 0. That's when there's an x-intercept. So I've got x equals 3 is one of them. Right? And so that corresponds to a factor of x minus 3. Going back to my table, there's another one at negative 1/2. So at negative 1/2. So when x equals negative 1/2, that's also an x-intercept. And that corresponds to a factor of x plus 1/2. And then I need to find the third one. Remember, looking back at the graph, there's a third one. And it looks like it's somewhere between negative 4 and negative 3. It doesn't look like the table. Let's scroll up a little to see if it shows it. Yeah, it doesn't, because here we know it's actually between negative 2 and negative 1.5, because that's where the output goes from positive to negative. But I can use my calculator to find out exactly what it is. And hopefully you guys remember this feature, but if you hit second and then trace, so you're really going into the calculate menu, the second option here is 0. So we can find a 0 using this calculate 0 function in our calculator. First, we need to find a point that is on the left of the x-intercept that we want. All right, so right there, I'm going to click enter. Then I need to find a right boundary, a point that's to the right of the intercept I want to find. There's one there. And then guess just means put the cursor somewhat in the vicinity of where the x-intercept is. And it looks like the 0 is at negative 1.66 repeating. All right, negative 1.66 repeating is the other 0. X equals negative 1.66 repeating. Well, guess what? That is the same as negative 5/3, right? That's negative 1 2/3. Same thing. Negative 1 2/3 and 5/3 are the same thing. So this will correspond to a factor of x plus 5/3. So I now have our 3 x-intercepts and I have a y-intercept. I can begin to write the function h like this. I need to leave a leading coefficient out front. And once I do that, I can just fill in with the 3 factors I already found. And how do I find what the leading coefficient a is? Well, I use the one other point that I know that's not an x-intercept, and that's the y-intercept here. So I know that h of 0 equals negative 15. And if I set negative 15 equal to a, and I plug in 0 for each of these x's here, I will get a times negative 3 times 1/2 times 5/3. I can go ahead and simplify this. A times, let's see, the 3's cancel out, and I've got 5 in the numerator, -5 half, which is the same thing as A times -2.5. Might be a little easier to see that then. All right, I'm going to divide both sides by -2.5. Cancels out over here. And what I'm left with is A equals -15 over -2.5. Put that in your calculator, you'll find that A equals 6. You can take that value of 6 and plug it in up here for the leading coefficient. And then we can rewrite our function of h like this. 6 times x minus 3 times x plus 1/2 times x plus 5/3. And that's how we can write the function h of x in factored form.